We're group 4. My name is Pablo Wada.
My name is Jeff Charles.
And I'm Yusuf.
Hi, I'm Mario Dura.
We're going to be representing experiment 1 for medical instrumentation.
This lab 1 is gonna explore like how Arduino can be used to control and analyze electronic components in practical applications. For the first part of this experiment, the Arduino control an LED light to create dots and dashes, patterns similar to Morse code, demonstrating precise digital signal control.
So
in part 1 of the experiment, I want to just explain the circuit setting. So we have the pin D2 connected from the Arduino to a resistor to the longest leg of the LED LED. Then the shortest leg is connected to ground.
So going based off of what Pablo said, as we have it connected to D2, we have our Arduino representing values of 0 and 1. 0 is going to represent a value of 0 volts, and 1 is going to represent a value of 5 volts, which is going to be turning our LED on. So we have the letter 4 for our true, and number 4 starts with the letter F, and the letter F is represented with dot, dot, dash, dot. So for the dot, we just have it turned on for 0.5 because we have the value of 1. That's going to be turning off for 0.5 seconds as well. And we're going to have that repeating a second time for it to be on for 0.5 seconds and then turning off for 0.5 seconds. But for the dash, we have the LED turning on for 2 seconds, and then it's going to be turning off for half a second, and then we're going to go to our final dot, which is going to be represented for 0.5 seconds, and then it's going to be turning off for 0.5 seconds. And let's just pan over here so we can show you real quick. I think that's perfect.
For part 2, a potentiometer and a photoresistor were used to adjust and measure the lid's brightness, like by dimming the LED and recording voltage changes. The lab light show how light intensity affects sensor output, highlighting the Arduino's flexibility in controlling and revising like physical systems.
So basically we have a potentiometer, and the potentiometer is connected to analog A0 to one of its legs, and then we have another leg connected to the 5 voltage being provided by the Arduino, as you can see right here for the yellow wire, and then we have the red wire which is connected to ground. Then additionally we have the photoresistor, which is connected, one of the legs is connected to the 5 volts, again provided by the Arduino. And the other leg is connected to a resistor, then to the ground provided by the Arduino, and then connected to the analog A1.
So here in the code, we have read analog on. So what it's doing is that in this for loop, it runs 700 times. So for each iteration, it reads the value of from analog 0, which represents the voltage of the potentiometer, and then it also reads the analog value of A1, which is the voltage of the photoresistor. It takes these values, it plots it on a graph from 1 to 700, and then on the y-axis we have the voltage of the potentiometer and the voltage of the photoresistor. Here we have our graph labels in time and seconds, voltage of V, our title of the graph, and the legends for both the potentiometer and the photoresistor. So here you can see a graph of it working in real time. The blue dot represents the voltage of the potentiometer, and the black dot represents the voltage of the photoresistor.
For the last part, so just addition to the second part, as you can see, the potentiometer is connected to the LED light by a resistor. That way we could have a subtle change of the power being supplied to the LED light.
And that's all. Thank you.